Hello folks, this is your 2024 February-March session, paper 1-2, and the question number is 8. The question is concerned with the chapter dynamics. It says two balls P and Q of equal mass, move along a straight line directly towards each other as shown. So they are moving towards each other as shown. The ball P has a velocity 1.30 meter per second to the right. Ball Q has a velocity 0.50 meter per second to the left. P and Q collide with one another. Yes, the collision is perfectly elastic and the total momentum is conserved. Yes, it has to. Elastic is something imposed by us, but momentum conservation is a natural law for any type of collision. Which diagram correctly shows the motion of P and Q after the collision? So we need to find which diagram shows the motion of P and Q after the collision. So since the collision is elastic, we have certain conditions that follow. So one of the conditions is that if UA and UB are the initial velocities, and if VB and VA are the final velocities. So this is VB, this is VA. So we have UA minus UB equal to VB minus VA. If the bodies are like this, so this is A is chasing B, this is UA, this is UB, and after collision A is like this is A, which will be VA, its velocity, and this will be VB, this will be VB. So initially A is moving faster, but later B will be moving faster. So UA minus UB will be the velocity at which these two approach each other before collision, and VB minus VA will be the velocity at which these two bodies get away from each other after collision. So we need to have this thing if the collision is elastic. So here this is P, this is Q. So we must have first of all UA minus UP minus UQ. Instead of A and B, I am using P and Q. It will be equal to 1.30 meter minus, again it is minus 0.50. So we have two minus here because this thing is negative compared to this. The formula has been derived according to this direction. So since the direction here reverse, we have to have this as negative. So this will be equal to 1.80 meter per second. So before collision, the velocity of approach between these two is 1.80 meter per second. Now let us calculate these for all of the others after collision. So in this case we have so now initially it is a UP minus UQ. Now it should be equal to VQ minus VP. Q should be front. So that's equal to, it is a 0.58 minus it will be 0.22. So this will be equal to 0.58 minus 0.22 equal to 0.36 meter per second. So this is not the correct answer. Next is we have got 0.40 and 0.40. That means the two body get attached to each other. So in this case we'll have VQ minus VP is equal to 0.40 minus 0.40, that's equal to 0. So this is not equal to this. Again, it's not the correct answer. So number C we have got this is equal to, first it is 0.99 minus, this thing has reversed, so it is minus 0.19. So this will be equal to 0.99 minus a plus will be 0.19. That's equal to 1.18 meter per second. So again it's also unequal. Now the last one. So the last one, VQ minus VP equal to 1.30 minus 0.50. Since this has reversed, it should be minus sign here. It is the same as this was equal to 1.80 meter per second. So since the velocity of separation is equal to velocity of approach, the relative ones, This also shows the elastic collision. This also elastic collision. So D should be the correct choice.